More than 300 years ago, in a small English village, a frail child was born too early. His mother feared he would not survive the night. But that child lived and grew up to change the way we see the universe. His name was Isaac Newton. Hi, everyone. This is Isaac Newton, the man who changed our view of the universe. He is famous for discovering gravity and inventing calculus. But do you know how he invented calculus? No. Well, watch this video till the end and you'll know. Early life. Isaac was born in 1642, the same year that Galileo, the great Italian scientist, died. He grew up in Worcester, a rural village in England. As a boy, Isaac was quiet, shy, and often lost in thought. While other children played, Isaac built little windmills, sundials, and even tiny mechanical toys powered by water. He wasn't the strongest child, but he was endlessly curious, always asking questions about how and why things worked. The plague years. When Isaac was a student at Cambridge University, the Great Plague struck England in 1665. The university closed, and Newton returned home. It was during this time away from professors, lectures, and books that Newton made some of his greatest discoveries. He sat in his garden, watching apples fall. One day, as the story goes, he saw an apple drop straight to the ground. This led him to a question. Why does the apple always fall downward? Newton began to think. The same force that pulls the apple to Earth must also extend far into space, perhaps even to the moon. If so, then the force that holds the moon in orbit is the same force that makes an apple fall. This was the seed of his greatest idea, the law of universal gravitation. But Newton wasn't satisfied with just gravity. He wanted to explain motion itself. He developed 3 laws of motion, which are still taught in classrooms today. An object will stay at rest, or move in a straight line at constant speed, unless acted upon by a force. Force equals mass times acceleration, F equals ma. For every action, there is an equal and opposite reaction. These laws didn't just describe falling apples, they explained the motion of planets, the flight of cannonballs, the tides of the sea, and even the swing of a pendulum. The scientist of light. But Newton's mind was restless. He turned to light itself. He passed a beam of sunlight through a glass prism and saw it split into colors. From this, Newton proved that white light was made of all the colors of the rainbow. He also built the first reflecting telescope, using mirrors instead of lenses, which gave clearer images of the stars. In just a few years, Newton had transformed the fields of mathematics, physics, and astronomy. Though brilliant, Newton was also complex. He was deeply religious, yet secretive about his beliefs. He studied alchemy, searching for hidden truths in matter. He could be reclusive, stubborn, and even quarrelsome with other scientists. But he was also humble about his achievements. Near the end of his life, Newton wrote, "I do not know what I may appear to the world, but to myself. I seem to have been only like a boy playing on the seashore, and diverting myself in now and then finding a smoother pebble or prettier shell than ordinary, whilst the great ocean of truth lay all undiscovered before me." Later life, Newton lived to old age, becoming Master of the Royal Mint in London, where he helped reform England's currency. He was knighted by Queen Anne in 1705, becoming Sir Isaac Newton. He died in 1727, at the age of 84, and was buried with honor in Westminster Abbey, alongside kings and queens. But his true monument was not a tomb or a title, it was the scientific revolution he inspired. In 1689, the English physicist Robert Hooke published a book called Micrographia, which contained detailed drawings of fleas, flies, and other insects. He also illustrated a thin slice of a leaf, showing its tiny network of veins. At the time, no one knew how Hooke had made these detailed pictures. Now, over 300 years later, we know exactly how he did it. You see, Robert Hooke invented the compound microscope by placing 2 convex lenses near each other. When light passes through these lenses, it bends. In a compound microscope, light passes through 2 sets of lenses, which magnify the image many times. Before long, scientists were peering deep into cells and discovering a previously unseen world. For Hooke, the tiny chambers inside cells reminded him of the rooms in a honeycomb, so he named them cells. Today, the compound microscope remains one of the most important tools in biology. And it all started with the curiosity of one man. The apple tree. Where exactly did this famous apple tree grow? Many people believe it was here, right outside Woolsthorpe Manor, Isaac Newton's family home. But recent research suggests the tree may have grown over there, along the lane leading to the village. Regardless, it symbolizes Newton's insatiable curiosity. Why do apples fall down? A simple question that changed the world. The monument. What if I told you this statue isn't real? It's actually a cleverly drawn picture painted on the wall of a Cambridge college. Every year, students try to sneak up and deface it, but it's been protected by an anti-climb paint that dissolves skin. Maybe they should be studying harder instead of pulling pranks. After all, this is their college's tribute to one of history's greatest minds. The controversy. Isaac Newton is often considered the greatest scientist of all time, but not everyone agrees. Some argue that Albert Einstein deserves the top spot. Others say that it's Stephen Hawking. Who do you think is the greatest? Let me know in the comments. Principia Newton was never the kind of genius who dazzled people with grand pronouncements. Rather, his brilliance lay in patient analysis, careful observation, and rigorous thinking. In 1687, he published his greatest work, the Philosophia Naturalis Principia Mathematica, or simply, the Principia. In this book, he laid out his laws of motion and universal gravitation, providing a mathematical framework for the entire universe. The Principia became one of the most important books in history. It showed that the same laws governed both the heavens and the earth. For the first time, people could describe the cosmos with mathematics, not just philosophy. Calculus. Isaac Newton did not invent calculus, but he did develop much of modern mathematical analysis. He used calculus to calculate the orbits of planets around the sun. However, the invention of calculus is credited to two men, Sir Isaac Newton and Gottfried Wilhelm Leibniz. Both independently developed the theory in the late 17th century. They both defined derivatives and integros, but they approached the subject in different ways. Newton looked at continuous change as an infinite series of discrete steps. Leibniz, meanwhile, thought in terms of instantaneous rates of change. There's a lot more to the story, but in the end, it doesn't really matter who invented calculus first. What matters is that we have calculus today. Thanks to the brilliant minds of Newton and Leibniz. Conclusion. Isaac Newton took the mysteries of the world, the fall of an apple, the motion of the planets, the colors of light, and revealed the hidden order beneath them. His discoveries became the foundation of modern science. For centuries, the universe seemed to follow Newton's laws, like a giant clockwork machine. And even today, his ideas remain at the heart of physics. From a quiet boy in a village to one of the greatest minds in history, Isaac Newton showed us that curiosity, patience, and reason could unlock the secrets of the cosmos. What do you think of Newton's contributions to science? Which discovery do you think is the most important? Let me know in the comments below. And don't forget to subscribe to Studio Einstein for more videos about amazing scientists. Please like my channel. Thanks for watching.